let's explore some stuff here. These are in slope-intercept form. Slope-intercept form, what's that? Okay, now those are the notes that we're about to do. We're going to talk about slope-intercept form. You have undoubtedly seen it, heard of it before, but we're going to explore it in a slightly different way, at least with this one word problem. But let's go back here for a second. So what was the y-intercept of this one? Well, it was 3. What was the y-intercept of this one? Well, it was 3. What was the y-intercept of this one? It was negative 3. This one was negative 5, and this one was negative 1, and this one actually was 0. So let me point out how I can tell that just by looking at the equation. I'm going to work my way from the bottom up. This is 3/2 x plus 0. It is the number that does not have an x with it. And here's how it works. The y-intercept would be the y value if x equals 0. So if I was to plug in x equals 0 for any of these, I would get that term to vanish, and I would have 3 left over. So the negative 1, see, there it is. There's your negative 1. Or the negative 5, there it is. Negative 3. Now in this case it's not the 2 because it's this number. It's the number that's not with the x. Because if the x was 0, we'd have 3 plus 2 times 0. 2 times 0 is 0, so we'd have 3 plus 0, and we'd just get 3. Okay, so was the graph increasing or decreasing? Well, this one was increasing. I'm going to abbreviate here. This one was also increasing. This one was increasing. This one was decreasing. This one was decreasing. And this one was increasing. And I want to explain why. So let me make this just a little bit brighter. That didn't change a thing, hardly, but oh well, we'll go with it. Let me look at the number in front of the x, and you know this as slope. So here's the number in front of the x. There's your 1. Oh, it was a positive 1. That was a positive 1, so it's increasing. This is a positive 2, so it's increasing. This is a positive 1/2, so it's increasing. This is a negative 2, so it's decreasing. And you understand the point at this point. So negative 2 is decreasing. Positive 3/2 is increasing. By the way, if some are increasing and some are decreasing, then some look like this and some look like this, and now I'm wondering what would make it look like that. Well, we'll talk about that later. So let's shift over to the notes, and here's the way the notes are going to run. I'm going to do the first part, and then I'm going to basically go through the first column, and everything else is up to you. And I'm going to work through quite a bit. So here goes. Slope-intercept form, you've seen it, you've heard it, you've used it several times. But we're going to go through it one more time. Y equals mx plus b. M is the slope. Y is at m and not s. Well, I'm going to give you my answer. My answer is that s looks like 5. And the real answer is because m comes from the French word for mountain. It came from the French word for mountain. And so it started with an m, and mountain kind of deals with slope. So this one is the slope. That's the real answer, to the best of my knowledge. This one is the y-intercept, and this is also known as the starting point. And you don't have to start there, but it's a really good place to start. And the y-axis is the axis that runs vertically. So I'm going to show you a real-world example, and then we're going to get into some graphs that can kind of relate to that. So you work as a painter, you charge $30 an hour, and let's just stop right there. You charge $30 an hour, so if you work an hour, you're going to charge $30. If you work 2 hours, you're going to charge 2 times 30, so 60. We could get all the way up to that sentence and realize that this is the rate of pay, but you're also going to get paid $100 for materials. So you had to buy paint or show up at the house and pay gas money or whatever. So $30 an hour plus $100 for materials. That is what you charge. So we're going to write a function. Function? What's that? Well, function would be like f of x or g of x. I'm going to call it p of x for paint, just because I feel like it. So p of x equals, well, I charge $30 for every hour, and I'm going to work x hours. So I'm going to charge $30 for every x. And this goes back to what I just said. If I work an hour, I'm going to have a 1 right here, and 30 times 1 is 30. If I work 2 hours, 30 times 2 is 60. But again, let's not ignore the fact that we have $100 extra that we're just going to charge because we have to buy paint, materials, and insurance, or whatever else. So we have already answered this sentence right here. Write the function that represents how much you would charge for X hours of work. There we go. We've done that. But now I want to know how much I would charge if I worked 4 hours. Well, here's where it gets kind of mathematical. We're going to plug in a 4, and it's going to look like that. We're going to plug the 4 into the p function. So 30 times 4 plus 100. And let's just not even use a calculator. We got this. So 30 times 4, that would be 120. 120 plus 100, 120 plus 100. You can skip a step if you like. $220. If I paint at your house for 4 hours, then I'm going to charge you $220. Sounds expensive? Well, then hire somebody else. How much would I charge if I work 10 hours? Well, it's going to be more than that, I can tell you. So P of 10, meaning I'm going to plug 10 into the P function. So 30 times 10 plus 100. So I'm going to do 30 times 10, that's 300. I'm going to charge $300 just for my hourly rate, and then $100. So $300 from the 10 hours I worked, and then $100 for materials. So I'm going to charge $400. So let's actually answer a question that's not on here. How much would I charge if I worked 0 hours? Let me write that down. So 0 hours. It's not really worded like a question, but if I work 0 hours, how much would I charge you? Well, if I work 0 hours, you probably shouldn't pay me anything, but let's be realistic. Based on the way the function is written, you order a paint job and then you cancel at the last minute. Well, you know what? I've already bought the paint. I've already shown up at your house to give you an estimate. I've already done $100 worth of stuff. I have worked 0 hours, so I would go 30 times 0 plus 100, and you can do this in your head, clearly. 30 times 0, 0, 0 plus 100 is going to be 100. So if you want me to paint at your house and then you cancel on me at the last minute before I ever work a single hour, sorry, we'll send you a bill for $100. That's just the way it is. And that's why this is the starting point. That's why in this case, this is the starting point. If I was going to graph this, a good place to start would be at 100. Now clearly that's not very practical to count to 100 to graph. So that's why we're going to use things like this. So here we go. We're going to start graphing these, and I'm going to use pencil. Hopefully it'll show up pretty well. And we're going to start with our starting point. This right here is our Y-intercept. I'll abbreviate it as Y/INT. And this is the Y-axis. This is the X-axis. You know that. I know that. So let's do it. The Y-intercept is not at 2. It's at -2. I'm going to start down here, -2, and I'm going to put a dot, using a pencil in case I make a mistake. Now, real quickly, let's go back here for just a second. It is increasing if the slope is positive. It's decreasing if the slope is negative. So let's look at the slope here. This is positive 1/2, which tells me this. Whenever I draw this thing, it's going to go not down, but up. This thing is going to have it does have a positive slope, therefore it will be increasing. So I'm going to increase. It's going to be tilted up. Well, now I have to make sure I tilt it the correct way, and you have heard this, but the rate of change is going to be equal to rise over run. So let's do this pretty quickly because you've seen it before. Sorry, didn't mean to bump the camera there. Your screen just shook. So rise over run, so we're going to rise 1. I'm going to rise 1. Notice where I'm pointing. Let me point with an ink pen. I'm going to rise 1 from my first dot, and then I'm going to run 2. Now, notice that everything I just pointed to was positive. I pointed to a positive 1 and a positive 2. That means up and to the right. And when I go up 1 and over 2, I have a second dot. Now, 2 dots, 2 points determine a line, but in order to make the line really good and straight for our purposes, I'm going to go again up 1 and over 2. Up 1 over 2. See where I'm getting it from? Up 1 over 2. I'm going to do that a couple more times. And actually, you can go backwards. I could go down 1 and to the left 2. And let me point out why very quickly. If I go down 1 and then I go to the left 2, that would be -2. -1 divided by -2, well, negative divided by negative is still a positive. I still have a slope of 1/2. That's why it's still falling on this line. So then I can grab a ruler. Let's use this ruler. There we go. There's my first line. I'm going to put some arrows on the end of it. Not a big deal if you don't for now, but you do need to understand that it goes forever in both directions. Okay, let's do the next one. I'm going to start here. Oh, what number am I pointing at? Well, I don't know. It's kind of hard to see. It's not there. Now, there are a lot of times you have an understood 1. Sometimes you have an understood 0. There is not an understood 1 here. It's not plus 1. I actually have nothing there. That's a 0. So this is my y-intercept. I'm going to start at 0, and then my slope is a half. It is positive 1/2. So when I'm done with this thing, it better be tilted up. Now, is it like that or is it like that? I don't know how tilted up it's going to be, but it is up. So, up 1 and to the right 2. Up 1 and to the right 2. Up 1 to the right 2. Up 1 and to the right 2. I'm going to go back with a 2. So down 1 and to the left 2. Down 1 to the left 2. Down 1 to the left 2. Pause the video if you need to. There we go. There it is. Okay, I said I'd do the first column, so I'm going to keep going. I'm going to move to the next problem, pause this if necessary to get all the dots right, put everything in the right spot. Don't have some sloppy line that doesn't run through your points, because when you get to the end of this packet, it's going to be really complicated to do if you're not drawing straight lines that go through all of your points. Okay. At this point, they start getting slightly harder. We're going to build up a little bit as we go, but we're going to start going faster. So 2, that is my y-intercept. That is where I start. It is a positive 2. So here's my y-axis. I'm going to start at 2. Here's 0, 1, 2. Boom, right there. There's my starting point. I need to use my slope. This right here is my slope. Now, I'm used to having a slope that's a fraction. See, up until this point, it was rise over run. It was 1/2, or 1/2, same problem. Well, this one's not a fraction. Well, man, I'll make it a fraction. Let me erase this little circle I drew. I'm going to make this thing a fraction. 3 over what? Don't say 0. You can't divide by 0. It's illegal. 3 over 1, actually. 3 divided by 1 is the same thing as 3. So I'm going to go from my first point. Don't go back to the origin. Don't do that. Start at your y-intercept. That is my starting point. I'm going to go up 3 and to the right 1. Now, the question might be, how do I know to go up? How do I know to go to the right? Well, let's look at it. That's a positive 3. Go in the positive direction 3. That's a positive 1. Go in the positive direction 1. So up 3 to the right 1. Those are both positive. I'm going to go up 3 more and over 1 more. I'm going to do the same thing here. So down 3 and back 1. Down 3 and back 1. Down 3 and back 1. All right, so here goes. Let's connect those right there, and we're going to do that. Okay? Are we good? Hope so. If you're not good, pause the video. Do what you need to do. Up until this point, all of our slopes have been positive, and the next one is as well. Now, some of the ones that you'll see in these are negative, some of those in a minute that have negative slopes, but I'm going to continue with the first column. So this is my y-intercept. My y-intercept is at -4. We start at 0 and we go 1, 2, 3, 4. It starts here. Okay, what number is in front of my x? Nothing. Is it nothing? Actually, it is something. It is something. There is a number there. It's an understood 1. There's an understood 1 in front of that x. I have 1x in this equation. Over in this one, I had 3x's. Now I have 1x. And, well, I need a fraction. I need a fraction. I don't want just a 1. I need a fraction. And that fraction is going to be 1 over 1. So I'm going to rise 1 and run 1. Rise 1 and run 1. Now, again, the obvious question is, how do I know my line goes this way and not this way? Well, I'll tell you why. That's a positive 1. If it was a negative 1, we'd be tilting down this way. Rise 1, run 1. Rise 1, run 1. I'm going to do that until I run out of graph. Do the same thing down here. Go -1, -1. Down 1 to the left 1. Down 1 to the left 1. You end up on the same line. We'll connect them. There we go. Okay, now we get to a negative fraction for a slope. It's not going to kill you. What doesn't kill you makes you stronger. I feel like singing. No, I'm kidding. I'm not going to. We're going to right here at the y-intercept, which is -3. So we're going to go down 3, and we're going to start there. That is our first point. From here, we'll use our slope. Well, our slope is -1/3. I'm going to use my blank space down here at the bottom to talk about that. So my slope is -1/3. Okay, what does that mean? Well, it means this. No longer is this line going to go up. Whenever I'm finished graphing, it's going to go down. Now, how steep it's going to be, we don't quite know yet, but I do know it's going to be tilted downward because it's negative. Okay, so here's my rise. Here's my run. But now I don't have a rise so much as I have a fall. Okay, let me explain. What I'm going to do, and you don't have to do it this way, but what I'm going to do is give this negative to the numerator. What I'm really going to do is treat it like this. I'm going to pretend like it's -1 divided by 3 instead of negative in front of the whole thing. They're the same thing. But now I'm going to take this and I'm going to not rise 1, but I'm going to fall 1. I shouldn't have put that dot right where I put it. Sorry. Not time to put a dot yet. I'm going to fall 1, and now I'm going to run +3. 1, 2, 3. There it is. I'm going to go down 1 and go 3 this way. If I do it again, then I run off the graph, which is fine. I'm going to go back this way, and I want to show you why that works. If I was to go back this way, I would go up 1, and I would go to the left 3. All 3 of these are the same. This negative can go in the front of the whole fraction. It can go with the numerator, or it can go with the denominator. I'm going to go up 1 and then back 3. Up 1 and then back 3. Up 1 and then back 3. And that runs. Okay. Let's put the on and let's draw. Oops. I was telling y'all to draw good straight lines, and then I messed up. I did kind of miss my dots there. Actually, the ones that I drew off the graph. Oh well. All right, let's keep on going. We're going to keep going through the left column. Pause it if you need to. Whoa, what do we have here? Okay, they're getting more complicated. That's okay. That is quite all right. So what we're going to do is write down some understood numbers. I'm actually going to just rewrite this whole thing. So this -x is really negative. Okay, let's stop right here. I know I have a number in the front, -1. So -1x. Oh, wait. That's my... I'm going to need a fraction. So let's make it -1/1 plus... I need a starting point. What is my starting point? What number is hanging around over here? Well, there's nothing. It's a 0. It's an understood 0. So I'm going to graph this. Okay, let's not get too crazy. Let me just point at the negative. Which way is it going to be tilted? Up or down? Down. It's tilted down. It's decreasing because it's negative, so it's going to go negative. How steep it's going to be depends on that exact number, and I start at 0. So, hey, I do start at the origin right there. We're going to go -1/1. I'm going to go down 1 and to the right 1, and I'll put a dot. That's enough to draw a line, but it's going to be crooked if you're not careful. So I'm going to go down 1 again, and then down 1 and to the right 1. -1 divided by +1. -1 divided by +1. -1 divided by +1. We'll do that until we run out of graph. Let's go back the other way. We could go +1 and -1. You get the same thing. +1 divided by -1 is the same thing as -1 divided by +1. All these end up being same thing. Up 1 to the back 1, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, up to the left, up and to the left, up and to the left. There we go. We have a lot of dots. Why did I do all those dots? Because we start graphing more than one equation and we have to find where we meet. These dots are really going to come in handy. Trust me. So if you're not feeling like putting them all, it's a good habit to get into because you're going to need them. By the way, when I get to that page, which is the very next page when you flip this page over. I'm not going to do the entire left column. I'm going to do just a couple of them and maybe start a third one. Maybe. We'll see what mood I'm in. All right, let's do the next one. Okay. Okay, here's the reason I put this one in here. This one is backwards. This one is backwards. Okay, very beginning of the notes. Slope-intercept form is y equals mx plus b. Here's another way of writing it. You can turn these terms around. Addition is commutative, meaning you can change the order of it. So I could say this is b plus mx. It's the same thing. bmx. Isn't that like a bicycle thing? So I can put the b in the front. Everything's positive, and I'm adding. Just turn it around. Turn it around. All right, so let's turn it around. I'm going to switch the order of these. That one, I'm used to it being at the end. Let's put it at the end. And it is a positive one. Now, I'm not solving. Don't start saying, well, I need to subtract. We get in the habit of doing that. No, that's not what we're doing. We're just taking these two terms right here, and we're swapping places with them. So 3/2 x plus 1. Okay? Here goes. We're going to start at positive 1. I'm going to rise 3. And I'm going to run 2. Okay, am I going to run to the right or the left? Look at my sign. Which way is this line going to tilt? Is this line going to be a negative or a positive? It's positive. So up 3, to the right 2. Up and to the right. Those are both positive. Up and to the right. Now we can also go down and to the left, down and to the left, and we do. We have this line right here. Okay, last problem that I'm going to do in this set before we turn the page and go to the next ones. Y equals -3. What does that mean? Okay, I don't have an x in this one. There's a lot of ways to explain it, but I'm going to do it. It sounds like the complicated way, but it's consistent with what we've just done. I have, in this problem, 0 x's. So I'm going to rewrite this. I have 0 x's, and I have a -3. That looks like ox minus 3. It's really 0x minus 3. So my starting point is at -3. So we'll put a dot here. Here's our first point on our line. Well, I'd love to have a fraction. Let's put it over 1. Okay? Our slope is 0 divided by 1. So I will rise 0. Well, that means I don't rise. That means I don't get up at all. So I'm going to rise or fall at all. It's 0, 1. And then I'll do it again. I'm not going to rise at all, but I'll run 1. You can see what's happening here. I'm going to end up with a completely horizontal line. I'm going to go backwards with it too, because 0 divided by -1 is still 0. So I'm going to the left one with each of these. And there it goes. There it is right there. Okay, let me show you the other way of doing it. And this is the quick way. It's hard to explain, but this is the quick way. If all I have is one letter and one number, let me rephrase it. If all I have is one variable, and my voice just cracked, one variable and a number, then I'm going to, follow me closely here, here's my y-axis, here's my x-axis. I'm going to cross that axis, sorry, there. I'm going to cross the y-axis at -3, and I did just that. Here was y-axis at -3, and I just crossed the y-axis. So if you look at this one, you're going to cross the y-axis at -1. It's going to just go straight across right here at -1. I didn't put any on here like this, but if I said x equals something, I'd cross the x-axis at that point. Okay, let's graph just a little bit. We're going to graph a system of equations, and we're going to do both of them. Okay, here's where we're going with this. You have found out what the x and the y are when you have an x and a y with another x and y. You have two equations and two variables. By the time I'm finished with this entire problem, I want to know this. You've done it algebraically, meaning you added equations, you subtracted stuff, you solved it. But now we're going to do it graphically because we have a graph. So let's do it the same way we've been doing everything so far. But this is where it really pays to be very, very careful. We're going to start at 5. What about this bottom one? Don't worry about him. I'm actually going to do this one in color and hope I don't make a mistake. I'm going to graph the top one in red. I'm going to graph the second one in green. And then I will point out my answer in blue. Okay? We're going to graph the top one in red. I'm going to start at 5 on the y-axis. 1, 2, 3, 4, 5. There's my first point right there. My slope is a half, so I will rise 1 and run 2. I will rise 1 and run 2 more. It is important to put as many dots as you can because one of these dots is probably going to be your answer. Rise 1 and run 2. It also helps if your lines are straight. Rise 1, run 2, rise 1, run 2. We're going to go backwards. Down 1, negative 2. 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 And we're going to connect them. Let's connect them right here. There we go. This is the first one. This is the red line. It's a thin red line. That was a joke. Okay, let's graph the second one. We start at 3. 1, 2, 3. The slope is negative 1 over 2, so it's not going to go tilting up, it's going to tilt this way instead. So up to 3, and then we're going to go negative 1, so we're going to fall 1 and then go to the right 2. Now, don't fall 1 and be like, oh, well, it's negative, so I'm going to go, no, that would make it go this way. I need a negative divided by a positive, a negative divided by a positive, negative divided by a positive, and you can just keep on going with that. Or you could do, that was a really long way of saying or you can go up and back, up and back, up and back, up and back. I hope you noticed what happened right there. This is where these two lines met. They met. They really hit it off. Okay. Here's the point, and that the pun intended. Here is the point of this. I want to know what X and Y are. I want to know where X and Y, where these two equations meet, and I want to name that with a coordinate. I want to name it. So negative 2, 1, 2, 3, positive 4. Negative 2, 4 is the equation that satisfies both of these. You don't have to do this. I'm going to do it on a little post-it note here. You don't have to do this, but what I'm doing is checking my answer. Well, how are you doing that? What I'm going to do is plug in negative 2 and 4 into both equations, just real quick to check it. I want to prove to you that it works. So if I have y equals 1/2 x plus 5, and I plug a 4 in for y, and a negative 2 in for x, I should get a true statement. 1/2 times negative 2 plus 5. Let's see, half of negative 2 is negative 1. Negative 1 plus 5 is 4. Negative 1 plus 5 is indeed 4. So sure enough, it works in the top equation. Let's try the bottom one. I'm going to go y equals negative 1/2 x plus 3. And if I plug in a 4 for y, I'm just checking my answer. Negative 1/2 times negative 2 plus 3. 4 equals, negative times negative is positive. Half of 2 is 1. 1 plus 3. Oh, sure enough, 4 is 1 plus 3. So sure enough, it works. This is it. I'm going to do one more and just give you some hints on some of the other ones. And that'll be it. The rest of them are up to you. Okay, I'm actually going to do the second one first. And actually, can I point out something kind of neat? You already know part of your answer. What is it? What do you already know? Do you know X or Y? You already know Y is 7 because they said so. I'm going to graph it anyway, though. So let's graph it. I'm going to graph this one in green. I'm going to graph the top one in red. So this one has no x value. You can call it 0x, just like you did on this one. But I'm not. I'm going to say, well, you know what? I'm crossing the y-axis at 7. So 1, 2, 3, 4, 5, 6, 7. And I'm going to draw a horizontal line right there. It may not show up well. It's kind of hard to see. I'm going to make it kind of bold. I didn't put a bunch of dots on it. I'm sorry. Okay, let's graph that top one, and I'm going to rewrite it actually. When I rewrite that, I'm going to call it 1x. Oh, wait. I need a fraction for my slope. 1 over 1x plus 0. So it starts at 0, rises 1, runs 1, rises 1, runs 1, up, over, up and over, up and over, up and over, up and whoa, see it? You see it? This is where they meet. This is exactly where they meet. And where do they meet? Let's count it. I want to get to here. I want to get to here. 1, 2, 3, 4, 5, 6, 7, comma. 1, 2, 3, 4, 5, 6, 7. They meet at 7, 7. Can I tell you how you could have just looked at that one and told the answer? And this is kind of cool. You already knew what y was, and y is the same thing as x. So I know they're the same. I know what y is, and I know they're the same, so they must both be 7. Okay, real quick, let me give you a couple hints on the rest of them. We'll zoom this out. There we go. This one has a negative slope. That one has a positive slope. So whenever you're done with this one, I don't know exactly what it'll look like, but you're going to have two lines that cross kind of like this. I don't know where it's going to land. This one is a lot like this one. You're going to have one line that's completely horizontal, and the other one has a negative slope. Okay? I'm not going to give you too many more hints. These are kind of alike. These three are very similar. These three right here. These three. And that one has a positive slope and a negative slope as well. So it's going to sort of make an X. Okay? There you go.